Hello everyone, today we will be starting with some important compounds of group 1 elements. Students are requested to drop down their names for attendance purpose. We will be starting in a while. Students are requested to drop down their names for attendance purpose. We will be starting in a while. Okay, so the first important compound that we are going to learn is sodium carbonate, right? Part of these compounds you must have read in your 10th class chapter also, right? In acid and bases like sodium carbonate, sodium bicarbonate, baking soda, washing soda. Some part of it you must have learnt in your 10th class. Okay, and some part will be new to us. So first we will start with sodium carbonate. Sodium carbonate molecular formula is Na2CO3, which is associated with 10 water molecules, right? And its common name is washing soda. Right. Now talking about the preparation of sodium carbonate, it is prepared by Solvay process. And what the Solvay process is based on is the low solubility of sodium bicarbonate. Right. So due to the low solubility of sodium bicarbonate, it gets precipitated, and when it is made, it is basically made with the reaction of sodium chloride with ammonium hydrogen carbonate. Right. So first we will learn the process here. See, ammonia plus water plus CO2 will give you ammonium carbonate. NH4 stands for ammonium, right, and CO3 2 minus stands for carbonate. So first we will obtain what? Ammonium carbonate. Now this on reaction with CO2 and water will give you ammonium bicarbonate, right? HCO3 is known as what? Bicarbonate, right? Now here, now ammonium bicarbonate on reaction with NaCl, it will give you what? Ammonium chloride plus sodium bicarbonate. Just an exchange of ions is being here. For example, NH4 and Cl are combining and Na and HCO3 are combining, right? You can remember this reaction this way, that double displacement kind of reaction is taking place here, that the cation is taking the anion of the other one, and here also the cation is taking the anion of the first one. Okay, now this sodium bicarbonate is heated to give sodium carbonate plus CO2 plus water. This has low solubility, right? It has low solubility in water. So these crystals basically are heated to give you what? Sodium carbonate plus CO2 plus H2O. Right, so this is how you can form washing soda. Now recovery of ammonia, right? We used ammonia in the production of sodium carbonate here. Now how can we recover ammonia that is used in the process? Just treat that ammonium chloride with calcium hydroxide. It will give you what? Ammonia plus calcium chloride plus water. So this is how you can regenerate ammonia. right, and where the calcium chloride is obtained as a byproduct. Now the question can also be asked here that while the recovery of ammonia, which is being used in the Solvay process, what is the byproduct that is obtained, right? So calcium chloride is the byproduct in Solvay process, where the recovery of ammonia is taking place by the reaction of ammonium chloride and calcium hydroxide. Okay. Now, why Solvay process cannot be used for other carbonate preparation? For example, let us say that we are having potassium carbonate as K2CO3. Why it is not used to prepare potassium carbonate but only sodium carbonate, right? The reason lies in the principle that on which basically the Solvay process is based upon, that low solubility of sodium bicarbonate is there, right, in water. But in case of potassium hydrogen carbonate, that means potassium bicarbonate, KHCO3, it is very much soluble to be precipitated by the addition of ammonium hydrogen carbonate, right? So basically, due to the higher solubility of potassium bicarbonate, right, and lower solubility of sodium bicarbonate, we are able to prepare what? Sodium carbonate from the Solvay process, but not potassium carbonate from the Solvay process. Okay. Now next is the properties. Now sodium carbonate is a white crystalline solid and it exists as decahydrate. Deca stands for 10, right? So 10 water molecules are associated with it. That is why it is called decahydrate. It is readily soluble in water. Its other name is washing soda. That means its common name is washing soda. On heating, what happens? That at 375 Kelvin, it loses 9 water molecules, right? One hydrate is still left, and when you heat it above temperature 373 Kelvin particularly, it loses this water molecule also and becomes what? Anhydrous sodium carbonate, right? So this is also known as what? Soda ash. Where no water molecules are associated with sodium carbonate, that is known as what? Soda ash, which is a white powder of sodium carbonate. Now, carbonate part of sodium carbonate gets hydrolyzed by water to form an alkaline solution. For example, what is the carbonate part of sodium carbonate? Obviously CO3 2 minus. Now this gets hydrolyzed by water. So water is having what? H plus and OH minus. This H plus basically combines with CO3 2 minus and OH minus is released in the solution, and due to the presence of this OH minus, the solution is alkaline in nature. That means it is basic in nature. Okay. Now, aqueous sodium carbonate react with CO2 gas to form sodium bicarbonate. So, sodium carbonate reacts with water in the presence of CO2. That means Na2CO3 plus water means what? That aqueous sodium carbonate reacts with CO2 to form sodium bicarbonate. Now, the uses of sodium carbonate. It is basically used for water softening, as we have learnt in the hydrogen chapter. Right? It is used for water softening, laundering and cleaning. It is used for the manufacture of glass, soap, borax. This borax we will be studying in the P block chapter. It is a compound of boron. Right? So basically it is used to manufacture borax, caustic soda. Then it is used in paper, paints, textile industries, and also it is used as a laboratory reagent in both qualitative and quantitative analysis. What is qualitative analysis? That you find out that what type of ion is present in your salt. That is a part of qualitative analysis. While quantitative analysis, if you will see that how much amount of a thing is present, that is known as quantitative analysis. Right? Now Na2CO3 plus K2CO3 is known as fusion mixture, and Na2CO3 plus calcium sulfide is black ash. Okay, this you need to remember by name. Now next we will learn about sodium bicarbonate, which is the baking soda that you use at your homes also, right? For baking things like in idli also it is used, right? In which a fluffy part is required, basically baking soda is used there. Okay, in cakes also it is used while you are baking the cake or you are baking the pudding, right? So sodium bicarbonate is also known as baking soda because it decomposes on heating to generate bubbles of carbon dioxide. Now these bubbles of carbon dioxide are basically responsible for leaving holes in cake or pastries, and this carbon dioxide basically makes them light and fluffy in nature. Here you can see that by the addition of baking soda, that is sodium hydrogen carbonate or sodium bicarbonate, the pastries or the puddings or the cakes become fluffy. Now next is preparation of sodium hydrogen carbonate or sodium bicarbonate, as we have already done in the previous slide, that on reaction of sodium carbonate, aqueous sodium carbonate with CO2, sodium bicarbonate is formed, right? Now next is the heating effect. So as we have already learnt in the introductory slide of sodium hydrogen carbonate or bicarbonate, sodium bicarbonate at 373 Kelvin, it decomposes to form sodium carbonate plus CO2 gas plus water. So this is the heating effect. On heating, sodium bicarbonate gives sodium carbonate and CO2. In aqueous medium, what happens here is that, now see here, H plus is there, OH minus is there, here Na plus is there and HCO3 minus is there, right? So Na plus and OH minus will combine to form NaOH, and H plus and HCO3 will combine to form H2CO3. It is a constituent of baking powder, right? And it is also used as an antacid. Basically what happens that when there is a more secretion of HCl in our stomach than that of what is required, then we take antacid because we have gastric problems and all, right? So acidity of stomach is cured by baking powder also. It is used in the medicine. It is it is present in Seidlitz powder. Seidlitz powder, you can break through here, Seidlitz powder. Basically what is Seidlitz powder? It causes effervescence with water, right? Basically when this powder is mixed with water, it causes effervescence. Now baking powder is a mixture of starch, sodium bicarbonate and potassium hydrogen tartarate. Now it is also used in fire extinguishers. In fire extinguishers, basically we use H2SO4, Na2CO3 and sodium bicarbonate also, or NaHCO3 also, because it releases what? CO2 gas, right? And this CO2 gas cuts the supply of oxygen gas, which is essential for fire. Now Na2SO4.10H2O is known as Glauber's salt. Anhydrous Na2SO4 is called salt cake. NaNO3 is called child saltpeter, and NaHS4 is called nitric cake, and mixture of Na2O2. Now you tell me, what is Na2O2? It is a oxide, it is a superoxide, or is it a peroxide? Anyone with the answer? What is Na2O2? Is it an oxide, superoxide or peroxide? We have already done this in the previous sessions. What is Na2O2? Is it sodium oxide, sodium superoxide or sodium peroxide? Anyone with the answer? What is Na2O2? Now this is your homework. You have to find out that what is Na2O2. Is it an oxide, superoxide or peroxide? I will ask you this question in the next class. So mixture of Na2O2 and dilute HCl is called oxone. Now this is important. When you take common salt and fuse it with a little sodium carbonate, maybe 5% to 10% Na2SO4 and some sugar, it acquires a dark purple color, right? So basically this dark purple color compound has a saline taste and it is very useful for digestion. In Hindi it is called kala namak or black salt or Suleimani namak, right? You must be using it at home also. So common salt, that is what NaCl, when you fuse it with what Na2CO3 and you add some sugar and 5% to 10% of Na2SO4, you get this Suleimani namak, kala namak or black salt, which is used for improving the digestion. Now the next compound that we need to learn is the, yes Dinesh, you are very much correct with your answer, good, it is sodium peroxide. Now next important compound is sodium chloride. So sodium chloride is what? The table salt we use right at home is the sodium chloride. So the most abundant source of sodium chloride is the seawater. We get that table salt from the seawater, which contains 2.7 to 2.9% by mass of the salt. Right? In tropical countries like India, common salt is generally obtained by evaporation of seawater. Here you can see that the beds of salt are there, right? So what is happening here? That evaporation of seawater is done and the salt is left behind. Now we collect this salt and then purify it, and it undergoes many processes and we obtain it as our table salt. Now salt obtained from seawater contains sodium sulfate also, calcium sulfate also, calcium chloride also and magnesium chloride also. So to obtain NaCl only, we need to remove these impurities, right? So what we do is that the salt we obtain on evaporation along with the impurities is called the crude salt. So it is dissolved in minimum amount of water and then it is filtered to remove insoluble impurities. Okay. Now this solution, see what is happening here. Let us say that we are having what? Impurities plus we are having what? NaCl here, right? Now let us say we are having insoluble impurities. So we dissolve these in water, in minimum amount of water, and we filter it. Because these impurities are insoluble in water, they will remain on the filter paper, or basically at large level we use different devices, right? So for now you can understand that the impurities will be left on the filter paper and you will obtain the NaCl, right? NaCl plus water in the beaker itself. Now this solution is saturated with HCl gas. So this helps the pure sodium chloride to separate out. Right? Now calcium and magnesium chloride being more soluble than sodium chloride, they remain in solution. So first we separate what? Insoluble impurities. Right? Now let us say the water which is left after filtration, we will be left with water plus NaCl plus soluble impurities. Right? Now we saturate this solution with HCl gas. What happens here is, on saturation, NaCl separate out as pure crystals and these soluble impurities are left behind with water. Okay, so this is how you can separate the insoluble impurities as well as the soluble impurities from the seawater. Now melting point of sodium chloride is 1081 Kelvin. It has a solubility of 36 gram in 100 gram of water. That means 100 gram of water is able to dissolve 36 gram chloride at room temperature, that is. Now the solubility does not increase appreciably with increase in temperature. However, the solubility will increase when you will increase the temperature, but the increase is not appreciable. Okay. Now what are the uses? Its most common use is the common salt or the table salt that we use for domestic purpose, right? And the next one is for the preparation of sodium peroxide, NaOH and sodium carbonate. As we have seen already that in the preparation of Na2CO3 we were using sodium chloride, NaCl, right? Now the next important compound is our sodium hydroxide. So first we will come out with the commercial preparation of sodium hydroxide, which is known as what? Kastner-Kellner cell. Right, in Kastner-Kellner cell we do electrolysis of sodium chloride. Right, for this working of this cell we will not go into much detail as it is not very much from the examination point of view. Remember that electrolysis of sodium chloride in Kastner-Kellner manufacture of sodium hydroxide. Right, now mercury we take, brine solution we take. What is brine solution? 30% of NaCl in water, right? Or you can write it direct as 30% of NaCl water solution. That means in water you are having 30% of NaCl, that is called brine solution, right? Or you can simply also write that solution of NaCl in water is known as what? Brine solution, right? Then we are having cathode and anode, right? So the electrodes are made up of graphite. Electrodes are made up of graphite. Yeah, so these are the components here. See, these are the slates which are used for partition. These black things you can see here, that these are the slates which are used for partition, right? This middle chamber is called the central chamber or central compartment, and these two are known as what? Outer chambers or outer compartment. Outer compartment. Now this all is the brine solution. That means NaCl solution plus water. Here is the brine solution. As you can see here, three of the compartments are having the brine solution as the electrolyte. Now mercury you can see here. Mercury. Here we place mercury. So this mercury is able to travel from here to there. That means it is present in the three of the compartments. It can travel from here to there. Right. So this all part is what? Mercury. There are three compartments in which the electrolyte is what? Brine. Then we are having what? Electrodes, that is made up of what? Graphite. One will be acting as cathode and the other will be acting as the anode. Then we have slate partition to basically categorize the chambers, the different chambers. The outer one are known as the outer compartment. These two are known as the outer compartment, and this one, the middle one, is known as the central compartment. Okay, so now we are in consideration with the products here. Different reaction take place in the outer compartments and the central compartment. So now we will see that what are the reactions which take place in the outer compartment and the central compartment. Now in the outer compartment, anode are graphite rods. In the outer compartment, anode is the graphite rod. This you have to learn. Okay, that what are anodes and what are cathode in different outer compartment and the inner compartment. Cathode will be mercury, right? This mercury will be what? Cathode. In the outer compartment, graphite will be what? Anode, and mercury will be what? Cathode, and the electrolyte will be the brine solution. Now at anode what happens? Oxidation takes place. At anode, oxidation takes place. Oxidation means what? Loss of electron. So here what happens, that Cl negative basically loses electron to give Cl2 gas. So here in the outer chamber we are obtaining what? Cl2 gas as the product. At cathode what happens here is that reduction takes place. Reduction is what? Gaining of electron. Gaining of electron. So here what happens, that Na plus electron will give you what? Sodium. Right. Here the brine solution is having what? Na plus and Cl negative ion. So Cl negative at anode will yield you Cl2 gas, which is let through the chamber through this outlet, right? And this Na plus get reduced on the cathode to form sodium. This sodium combines with the mercury to form sodium amalgam, NaHg, that is sodium amalgam. Now in the central compartment, now anode is what? Mercury, and cathode is what? Iron rod. This is important, right? In the central compartment you can see here, these are the iron rods basically. Iron rod which serve as cathode. and anode is what? This mercury. Mercury will be the anode here, and electrolyte will be what? Dilute solution of NaOH. Now this is also very important. In the outer compartment we were having what? Brine solution as the electrolyte. Here the electrolyte is what? Dilute solution of NaOH. Now at anode what will happen? That oxidation will take place, loss of electron will take place. So OH minus will give you OH plus electron. Loss of electron is taking place through the electrolyte, through the negative part of the electrolyte, that is OH minus, right? And at cathode what happens here is that H plus gains electron to form hydrogen gas, which is let out through the central chamber through this outlet, right? So hydrogen gas is released from this outlet, right? Now this OH which is obtained, it combines with the sodium amalgam to form NaOH plus mercury. So these reactions you have to learn. Basically you have to learn that what are the products in the central compartment, what is serving as anode, what is serving as cathode, and what is serving as electrolyte. Okay. Now next, the properties of sodium hydroxide. So sodium hydroxide is a white translucent solid. Here you can see the image of sodium hydroxide, right? Now its melting point is 591 Kelvin. Okay, so such compounds are known as what? Deliquescent compounds. Now your homework is to find out that what is the difference between deliquescent and hygroscopic compounds. Deliquescent and hygroscopic compounds. These differences you have to find out, right? Now the sodium hydroxide solution at the surface reacts with CO2 in atmosphere to form sodium carbonate. So NaOH plus CO2 gives you what? Na2CO3, right? So this is another preparation for sodium carbonate. Now its reaction with salt. So what is NaOH? It is a base, right? It is a base. So it reacts with metallic salt to form hydroxides, out of which some will be unstable and decompose to insoluble oxides. For example, FeCl3 plus NaOH will give you what? Ferric hydroxide, FeOH3, right? So this is insoluble in water. That is why we are having a precipitating sign here. Formation of unstable hydroxide. So if you take AgNO3 plus NaOH, it will give you what? AgOH. Right? Now this AgOH is very unstable, so it decomposes to insoluble oxide. That means it will convert into silver oxide, which is a brown PPT in water. It is insoluble in water. Now formation of insoluble hydroxides which dissolve in excess of NaOH. Now this is very important. You need to learn these metals. Very important that these are soluble in NaOH. Zinc, aluminium, antimony, lead, tin and arsenic. This was a direct question in JEE, that out of the following metals, which one are soluble in sodium hydroxide, right? So you have to remember that these metals are soluble in sodium hydroxide. So zinc sulfate, again it is a metal salt. On reaction with NaOH, it will give you what? Metal hydroxide, that is zinc hydroxide, which is soluble in excess of NaOH and it forms what? Sodium zincate, that is Na2ZnO2. Now next is from ammonium salt. For example, we are having ammonium chloride here. You treat it with NaOH, it will liberate ammonia gas with the formation of NaCl. Right? So ammonia gas will be liberated here. Now next is the reaction with halogens. So with halogens, if you are taking cold NaOH and you are reacting with, let us say, Cl2, right? So you will get what? NaCl plus sodium hypohalide, that means NaClO, right? Now if you treat it with hot NaOH, then it will give you sodium halate, that means NaClO3. The product is changed. When you treat it with cold NaOH, then you will form hypohalite. When you will treat it with hot NaOH, then you will get the product as NaClO3, that is sodium halate, right? Now here remember that these halogen cannot be fluorine. right? These are only what? Chlorine, bromine and iodine. Now next is reaction with metals. Now less electropositive metals, for example zinc, aluminium, tin, they liberate hydrogen gas on reaction with NaOH. So this reaction also we have learnt in 10th class, right? So zinc plus NaOH, zinc plus NaOH will give you what? Sodium zincate, and it will liberate what? Hydrogen gas. Now reaction with sand. So sand is what? Silicon dioxide, SiO2 is sand, right? So NaOH plus SiO2 will give you. Any questions? Or shall I wrap up the session? Okay, so we will meet in next class now.